Okay, let's look at identities. This might take a while. Right, okay, cosine x, cotangent x plus sine x. Right, I'm going to change this cotangent to cosine over sine. So I'm going to have cosine x and then cosine x over sine x plus sine x. Okay, now if I multiply these two together, I've got cosine squared x over sine x. Now I'm going to have a common denominator, so I'm going to have to change this sine x to sine squared x over sine x. It's basically I've just added an extra sine x to top and bottom, okay? So I've now got cosine squared x plus sine squared x on the top with sine x on the bottom. Now, if you know your identities again, remember that is 1. Cosine squared x plus sine squared x is 1. 1 over sine x is cosecant x. Okay? Right. Keep on going. I know, these aren't too easy. Right, let's take a look at the next one. Right, cotangent squared, tan squared. Right, this here, that right there is cosecant squared x minus 1 plus that right there is secant squared x minus 1. Okay? Now, if I add all these together, here we go. I've got the cosecant squared x plus the secant squared x, and -1, -1 is -2. Okay? Now, cosecant squared x is 1 over sine squared x. Secant squared x is 1 over cosine. Sorry, 1 over... That's right, 1 over cosine. Yep. Cosine squared x minus 2. Okay? Right, common denominator is sine squared x, cosine squared x. All right, I'm going to end up with this. Put both denominators together. I've got sine squared x, cosine squared x on the top. Okay, this is going to go there. That's going to go there. So I'm going to have cosine squared x plus sine squared x. Remember, I'm just doing common denominators. Okay, minus 2. Well, again, that is 1. Okay, so we have 1 over a sine squared x. We've also got a 1, well, we don't need that again, over the cosine squared x minus 2. Now remember, 1 over sine squared x is cosecant squared x, sorry. 1 over cosine squared x is the secant squared x. So basically that is this, all right? And then the minus 2. That's what that is there, okay? Not great, eh? Okay, let's keep on going. Next one. So where's this from? This is from 6.3. Right, okay, so let's take a look at it. Question, what was this one? What we're doing, question 26 from here. Right, okay, actually this is not too, this is pretty quick, this one. Cosine of 2x, okay, is 1 minus 2 sine squared x. Okay, that's that bit. I've still got the 2 sine squared x. All right, that's that there. Okay, so because those will cancel, okay, -2 sine squared x, positive, what's 1 plus 1? Is 2. Okay, right. Now, I know this last one dragged on a little bit in class, this last one here, but let's just take a look at it. Where's this from? 6.2. Okay, so, oh dear. That is the rule x plus y, the rule x minus y. So, sine of x plus y is, I'm going to have to go up here, sine x cosine y plus sine y cosine x. That's that. Multiplied by this one. So the rule for this is very similar. Sine x cosine y, but minus sine y cosine x. The only difference in those two is just the sign right there in the middle. Right, if I multiply all this together, right, sine x times sine x is sine squared x. Cosine y is cosine squared y. Okay, I just did the first. Now, fortunately, looks like these, because they're conjugates, the outer and the inner will cancel because they're conjugates. You can check that yourself. All I've got to do is the last. Positive times negative is negative. Again, sine y times sine y is sine squared y. Cosine x, cosine squared x. Right, okay, now I can change cosine squared y to 1 minus sine squared y. So, sine squared x times 1 minus sine squared y. That's that bit changed. Minus sine squared y still. And again, I can change this to 1 minus sine squared x. 1 minus sine squared x. Okay? Right, let's do the distributive law. We have sine squared x minus sine squared x sine squared y. That's that. Okay. Minus sine squared y. And then positive. Okay, that's going to give you a plus, okay. Sine squared y plus sine squared x sine squared y. Sine squared x sine squared y. Okay, there's got to be lots of things cancelling here somewhere. Yeah, that cancels with that. What I'm left with is sine squared x minus sine squared y, which is exactly what we're looking for. Again, not easy.